Hello everyone, myself Chandrasekhar, welcoming you all to this incredibly wonderful daily dose series for civil and mechanical engineers. As you guys are already aware that in this series we bring an important concept or sometimes a question and discuss in short duration and try to make it simple, easier for you to understand. So in this series today I will be going to discuss one of the important concept of fluid mechanics, one of the important property of the fluid that is viscosity, and we will talk about an important device which is used to measure the viscosity of a fluid. Do you know what is that device called? The device is called as viscometer. So in today's session, we will discuss about the viscometer, how it works, and we will talk about the Newton's law of viscosity. What is the significance of viscosity? And that all will be discussed through a question. All right. So first of all, let us try to understand what exactly is a viscometer. Viscometer is a concentric cylinder. It is a device which is made up of two concentric cylinders. There is an inner cylinder, there is an outer cylinder. And inner cylinder is rotating, whereas the outer cylinder is fixed. And the gap between these two cylinders, is filled with a liquid for which we want to calculate or we want to determine the viscosity. All right. So, but before I start my session, let me quickly introduce myself. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have cleared engineering services examination also. I have worked in SAIL also for a couple of years. All right. So let us start discussing about the question. The question says the viscosity of a fluid is to be measured by a viscometer consisting of two 40 centimeter long concentric cylinders. So the length of the cylinder is 40 centimeter, that is 0.4 meter, isn't it? The outer diameter of the inner cylinder, which is rotating, that is 12 centimeter. So small d, that is the diameter of the inner cylinder, is 12 centimeter. We can call it as 0.12 meter. And the gap between the two cylinder is 0.15 centimeter, or we can call it as 0.0015 meter if we put all the parameter in their assignment. The inner cylinder, which is rotating at 300 rpm, revolution per minute is 300, and the torque measured on the inner cylinder Ti is 1.8 Newton meter. Torque is measured, that is 1.8 Newton meter. Find the viscosity of the fluid which is kept between these two cylinders. That is how the question looks. All right. So these are the given parameters, and based on these given parameters, we can find out the viscosity of the fluid which is kept inside, which is kept between the gap between these two concentric cylinders. So if we talk about the Newton's law of viscosity for linear velocity profile in the fluid, if we assume the velocity profile to be linear in the fluid, then we can say the shear stress developed in the fluid, which can be written as tangential force on the inner cylinder per unit shear area on the inner cylinder, which is equal to mu viscosity into tangential velocity of the fluid particles in contact with the moving surface divided by the thickness of the fluid. This is the inner cylinder is moving surface. So the tangential velocity of the fluid particle which are in direct contact with the moving surface. This is the axis about which the cylinder is rotating, right? What is V? If the distance from the axis is d by 2, so V is equal to omega into d by 2, and omega can be written as 2 pi n by 60 into d by 2. So V will be equal to pi into d into n by 60, isn't it? So this is how we can write the expression for shear stress developed in the fluid. So the torque which is developed on the inner cylinder is equal to tangential force acting on the inner cylinder into perpendicular distance from the axis, that is d by 2. And how to write FTI? That can be written as tau into area of the inner cylinder into d by 2, isn't it? That is how we can write it. And shear stress can be written by using Newton's law of viscosity. So the expression says Ti is equal to mu into V by H, that is shear stress. Area of the inner cylinder, the area which is in contact with the fluid, this will be the area of the inner cylinder, peripheral area, pi d into L. That will make the shear force into d by 2. If you put all the parameter, only unknown is viscosity. So Ti will be equal to mu by H into V is equal to pi d n by 60. That is the shear stress into pi d L. That is the area multiplied by d by 2. So if we put the values, 1.8 is equal to mu is unknown, thickness is 0.0015 into, we write pi into diameter, that is 0.12 into n, that is 300 upon 60, then into pi into 0.12 into length is 40 centimeter, that is 0.4 into d by 2, that is, what is d by 2? 0.06. So if we solve this question, if you will solve without any calculation mistake, then you will get the value of viscosity of the unknown fluid. That is how the Newton's law of viscosity is used in the viscometer to find the viscosity of the unknown fluid. It will come out to be 0.158 Newton second per meter square, or we can call it as Pascal second. The unit will be SI unit when all the given parameters are taken in their SI units. I hope this is clear. So that is how we can apply the Newton's law of viscosity to find out the viscosity of unknown fluids through the help of a viscometer. So that is all from my side, guys. Thank you very much for joining in, for having this session. I will see you again in the next such session. Till then, enjoy, take care, have a good day and a great future ahead. Thank you, guys. Thank you very much.